Let's get started. If you're trying to join, you'll see the join code at the top. You go to join.nearpod.com. And I'll put this one more time in the chat if you just want to click on the link. All right, let's get started. Conic sections. In this module, you'll learn about conic sections. When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface obtained is called a double right circular cone. All right, now I'm going to wait a few minutes for you to answer. Now, if you're not logged in, let me scroll up so you can see. What do you call the figure formed by taking a fixed vertical line and intersecting it with another line at a fixed point, then rotating the second line around the fixed point in such a way that the angle alpha remains constant? What is the surface generated called? Now, if you did your review of your vocabulary, this will be a little easier for you because this is going to go kind of fast if this is the first time that you've seen this. So I have 53%, more than half of you that have not answered. Thank you for those of you that have. Okay, some of you are saying nap, and you are on the right track. It is not a sphere, but there's two of them. So it's going to be a double napped right circular cone. Everybody click that button. Okay, so where are you, the 27.8%? Okay, I'm going to go back and look at this a little bit later and check on you to see if you're having technical difficulties. You should be able to click on the right answer. We're going to move forward. All right, it is a double napped right circular cone. A double right circular cone consists of two cones joined at a fixed point called a vertex. The line that rotates about the vertex is called the generator. All right, they just talked about two words, vertex and generator. Are you paying attention? Okay, but it's only going to be two. It's either vertex or generator. It's not the axis. They talked about the axis earlier. So let's focus on this. What do you call the point where a double nap cone, like an ice cream cone, where those tips touch? What is that? Is it a generator, an axis, or a vertex? Now we saw earlier the axis is going to be that straight line where that another line rotates and forms those cones. And it looks like everybody's saying vertex, and you're correct. But I still have 30% of you who are not answering. Now we use Nearpod a lot, but if you are new, you may be one of those students who are trying to figure all this out. So don't worry. Take notes. It is a vertex. Let's move on to the next part of this. And the line that remains fixed is called the axis. All right, now, very quickly, what is that line, that perpendicular line from the base? It's got two bases, top and bottom, that stays fixed. And there's two parts. And earlier, we talked about the line that rotates around that perpendicular line to form the cones. So what is the fixed line first, and what is the line that rotates? Is the fixed line the vertex? We can scratch that out because we know that the vertex is something else. So we can see the lines. The vertex is a point. We have two lines, an axis and a generator. The generator generates the cone, so it's going to be the one that rotates. The axis is going to be the one that stays fixed. All right, so the answer is B. Are there any questions before we move forward? I'm going to stop helping you so much because we are into this and I want y'all to really stay focused. All right, I still have 14% with no answer, but we're going to have to move forward. Any questions?
The right circular cone has a circular base, and its axis is always a perpendicular line from the center of the base to the vertex. The circumference of the base is called the directrix. The lateral surface of the right circular cone is called a nap. A double right circular cone has two naps. The nap above the vertex is called the upper nap, and the one below the vertex is called the lower nap. Also, the angle between the generator and the axis is called the vertex angle.
I want to stop that for a minute. Let that sink in if you're writing this down. Okay, in the chat box, what is this line right here? The one that stays perpendicular. Okay, that's the axis. And what is the line that rotates? This line right here, we don't see it rotating, but it goes around to form the cones. What is that called? The generator or the generating line. Good. To generate something means to create. So this rotating line is creating the cones. And then that surface, that three-dimensional surface, I think Catherine said this, is called the nap. Okay, so let that sink in. Don't want this to go too fast. Are y'all ready? That's the upper nap. That is correct. And the one on the bottom, what is that called? The lower nap. Y'all are awesome. All right, let's keep going. What do you call one of the two equal pieces, one of the pieces of a double cone when the cones are connected at the vertex by a plane? So we're taking a plane and we're slicing it right at the vertex. And it cuts that into two cones. So what do you call one of the two equal pieces when they're sliced at the axis? Now, y'all said this earlier in the chat. If y'all can remember and you're paying attention and you're looking, most of you are getting this right. Yes, it is a nap. The double nap is what we're going to look at when we generate our conics. The vertex angle is the angle that's formed by the generating line and the axis. So the answer is nap, and I wonder where those 14% are. Let's move forward. I don't know if they're ever going to answer, but let's just go ahead and move forward.
Let's look more into conic sections. If a plane intersects a double right circular cone, we form two-dimensional curves of different types. These curves are what we call conic sections. Depending on the angle made by the plane with the vertical axis of the cone, the plane can cut the cone in three different ways. First, we have an ellipse. When the plane intersects the double right circular cone in such a way that the angle between the plane and the x-axis is greater than the vertex angle, we get a closed curve called an ellipse. When the plane is perpendicular to the axis, the ellipse becomes a circle. Remember that a circle is a special type of ellipse. Just like a square is always a rectangle, but a rectangle is not always a square. A circle is always an ellipse, but an ellipse is not always a circle. Parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. Hyperbola. The plane intersects only one nap of the double right circular cone, as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. However, if the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane will intersect both the naps of the cone to form an open curve called a hyperbola, which has two disjoint curves.
All right, now there was a lot in there, but again, if you preload that vocabulary before you come to class, which is a weekly requirement, then this is a review, okay? But do your best, if that was going a little too fast for you, to answer, please. Which conic section intersects only one nap and contains a circle as a special one of these? So there's a couple of hints in here. If you think back to geometry in high school or geometry in middle school, it mentioned this several times. So this is formed when that plane intersects only one nap. So think of it as slicing through that top part of the cone, called the nap. What would it form? And a circle is a special one of these. So there's your hint. Is it a parabola? Would a circle be a parabola? Is it a hyperbola? Well, a hyperbola has two parts, so it involves both parts of the cone. So that's out. So it's either a parabola or an ellipse. But it is an ellipse because we know that a circle, good job guys, fits inside of that category. A circle is always an ellipse, but an ellipse is not always a circle. Any questions about that? Y'all are doing great. Okay, if you want to go ahead and put your answers in.
Degenerate conics. If the plane intersects the double right circular cone at its vertex, the ellipse becomes a point. The parabola becomes a line, and the hyperbola becomes two intersecting lines.
Now I want to let that sink in for a minute. So let me go back and watch as the plane moves from the cone down to the vertex and then tilts. We're taking a two-dimensional object, which will degenerate into a one-dimensional object. Take notes, pay attention, because we're going to put this into practice, okay? Now watch that again.
Conics. If the plane intersects the double right circular cone at its vertex, the ellipse becomes a point. The parabola becomes a line, and the hyperbola becomes two intersecting lines.
All right, let's see if we can put that into words. So let's translate the visual. A lot of this is like geometry. We've got to translate the visual into words. If the plane intersects the double right circular cone at its vertex, what does the parabola become? Now we're talking about a parabola. Is it a point, a line, two intersecting lines, or it's okay to guess. Now, don't feel bad if this isn't sinking in. I struggled with geometry and I'm a math major because the visual part is hard for me. It comes easy for some of you, but it did not come easy for me. I had to work really hard and practice, and I often stumble. So the good part about this class is that we encourage each other and we lift each other up. So I'm not afraid to take chances. So I'm getting a lot of different answers. A point, a line, two intersecting lines. All right, so let's look at the answer. And if you don't know right now, it's okay because we're going to build on this. But again, you would go back and look at the visuals and look at the study set that I have for you. If you're completely lost, don't know where it's at because we've got a whole new group, just send me an email and I'll do my best to get back to you quickly. All right, let me see. What do you think it is, guys? We're talking about a plane that intersects that double right circular cone at its vertex. The parabola becomes, I think it might be point. Let's look. No, it's a line. Because think about a parabola. Parabola is like this, okay? But it's hard for me to visualize it. So all of you that did B, congratulations. Okay. All of you that answered the rest, which is the majority or no answer, we're still learning. So don't be intimidated by that.
The figures that are obtained are called degenerate conics. So in this module, the vocabulary you have learned: when a plane intersects a double right circular cone, two-dimensional curves called conic sections are formed. There are three types of conic sections: ellipse, parabola, and hyperbola.
I'm going to stop there for a minute because some of you are not in this. So go ahead and jot this down. Everybody's going to have to answer or talk about what we've covered. So I'm going to give you 2 minutes when we get to the end of this to stop and just let you write.
When the double right circular cone is cut by a plane so that the angle between the plane and the axis is greater than the vertex angle, the ellipse is obtained. When the plane is perpendicular to the axis, the ellipse changes into a circle. If a double right circular cone is cut by a plane so that the angle between the plane and the axis is equal to the vertex angle, the parabola is formed.
All right, I'm going to stop right there. Now, I know you can't see through the arrow. All right, but here's a hint. Some students yesterday said screenshot time, and that's great, but you have a better way to deal with your vocabulary when you come to class, and that is to have Quizlet, the Quizlet study set open. So those of you that have it open, you already have all this in front of you. Okay, tell me when you're ready in the chat box to move forward. We're not going to take more than 2 minutes, so I'm going to turn the timer on. Just come back and say ready. Thank you, Khadijah and Ethan. About 15 seconds, and we're going to move forward. So have this vocabulary available throughout the lesson, and I'm going to really ask for you to keep your eyes on the screen and help me out at the board, especially when I do not see the chat. So somebody, if you can just, like you've done before, help me monitor the chat. All right, it's time for us to move forward. Let me see if there's anything in the chat that I'm missing. All right, thank you.
If a double right circular cone is cut by a plane so that the angle between the plane and the axis is less than the vertex angle, the hyperbola is formed. And if a plane intersects the double right circular cone at its vertex, the figures formed are called degenerate conics.
It's a lot of words. So study that study set. You've got one more question. How many types of conics are there? Do y'all remember? Is it 1, 2, 3, or 4? And if you're not in the Nearpod, type in the chat box. Is it 2, 3, or 4? All right, I know that there was a circle and an ellipse. Parabola. Think about your quadratics. Hyperbola. Was there anything else? Is there 3? Or I know there's at least 3. All right, so y'all are getting in between 3 and 4, something to go back and review in the vocabulary. I don't see anything in the chat box. Ethan, are you with us? Maggie? Jasmine? Francisco? Can y'all answer in the chat box? Crystal? Demaya? You're in class. I need your help. Luis? Abby? Jake? Thank you. Thank you. All right. Some say 3. All right. Well, we're going to figure that out. But there are some things that you need to study. All right, guys. Thank y'all for your participation. I'm going to go ahead and stop this activity. And we're going to go back to our lesson. Are there any questions about what we just did? We took a little bit more time than normal, but we do have some new students in here, so we wanted to slow down and demonstrate that. All right, we're going to go through this second part pretty quickly because 3.01 and 3.02 is all that you have to do this week. All right, but you know that you've got to get into the course, not just look at the assignments, but get into the course, look at the announcements, go through the instruct, and take notes. And use those notes on your quizzes and on your tests. Because if you don't, you're just trying to do the assignments, you're not going to really get the practice that you need. Pre-cal, you're going to see things maybe that you know before, probably that you know before, but in a different way. So you've really got to get involved. And these visual tests are a challenge to many of us, like me. Is there a question? All right, so we're going to be identifying different types of conic sections by how a plane intersects a double nap cone. And then we're going to be talking about the midpoint, translating that into 3 dimensions. So 3.01, you had a vocabulary challenge that was due. If you haven't done that, you need to go back and really get into the vocabulary. And the instruct piece means open up the course and take notes. Do the practice. Do not skip that. Live class yesterday and today, and then tomorrow you've got the instruct in 3.02. So let's go over what's in 3.02. It's the midpoint formula.
Sorry, someone's asking a question in the chat.
Thank you. Sure, go ahead. Either type it in or get on the mic. Oh, good question. That assignment was submitted or created, and that's how I'm not perfect either. I created it incorrectly, so it's asking for you to submit something, but you don't have to. But from your end, to make that notification go away, just submit a blank piece of paper, and I'll update the grades. I have to grade that myself, okay? If you want to be nice, submit something motivational, because I get worn down with the grading. It just gets tiring. And I know you get worn down too. So let's support each other. Does that answer your question? All right, let's look at the midpoint formula. If you remember from geometry, we take 2 points and we have a point. My tools are not working and the recording's not working. So we're going to make this work, guys. Don't seem to be able to write on the board. Hold on. All right, there we go. All right, so we have 2 points, and then we label them x sub 1, if you remember back in geometry, and y sub 1, so that we can keep track of these 2 points and don't get them all intertangled. And then we have x sub 2 and y sub 2. I'm putting this as a contrast to the way that this formula is written, so you'll understand they use x sub a and x sub b. So don't let that confuse you. I think so. I think you're right. All right, there's not a lot there, but they do kind of challenge, they really challenge you because they don't give you simple numbers. They pull in fractions and complex numbers. So what happens is basically you take your x values and you add them. Doesn't matter what order. What is 8 plus -3? Type in the chat box or get on the mic. Help me out. I don't have my calculator here, so I really am going to have to rely on you. All right, so I think it's 5, and y'all are saying it's 5. And then what is 5 divided by 2? So you take an average of those two numbers. So you got that part right, 2.5. So we've got our x coordinate. That's our midpoint. Now we need our y coordinate. What is 5 plus -1? That's right, it's 4. And what is 4 divided by 2? 4 divided by 2 is 2. So that's how you find the midpoint. Let's put that into practice. I'm going to give you 30 seconds, but I'm not starting the timer yet. I'll tell you when I start the timer. We have 2 points, 3, -6, and -4, -3. What is the midpoint of that straight line segment? Do you remember what we do? Add the x values and divide by 2. Add the y values and divide by 2. But look at the answers. You're going to see that you're going to have to think about it. Don't rush through this. I'm going to pull up the poll, and you're going to put in answer A, B, C, or D in just a minute, and I'll start the timer. All right, once the timer goes off, I'll give you a few more seconds. All right, so 30 seconds, guys. Still have 20 seconds. And some of you are helping out in the chat. All right, do y'all need more time? Do you need another 30 seconds? That felt rushed to me. All right, I'm going to give you another 30 seconds. Ignore that sound. I'm having to start it over. All right, keep going. Add the two x values and divide by 2. Most of you are saying D, and the answers that I see in the chat are also D. So let's take a look at that. 3, take away 4 is -1 divided by 2. So we can scratch these out, our x values. All right, there we go. There's our timer. Our x values are going to be -1/2, so we can eliminate A and B. So now we're going to work on our y values, -6 and -3. That's -9. Yes, thank you. And then divide by 2. So we look at the way, when I got answers for the Unit 1 test, y'all were mixing up decimals and fractions. What is the preferred way at this level to enter an answer if I don't tell you how? Fraction or decimal? What's the preferred way? How do you get an exact answer? Simplify fraction. Yes, because when you put it in decimal form, it introduces, or it could introduce an error, okay? So if you're not told, preferable way is in fraction. But I can see that this is a reduced fraction, not an improper fraction. So divide 2 into 9, it goes in 4 times with 1 remainder, and we're dividing by 2. This goes back to our long division, and it's negative. So D is our answer, okay? I have a few people that said B, a few people that said C, but the majority of you said D. Any questions about that? Okay, so are you seeing now how to do it? All right, let's move forward. All right, your turn. Now, I want you to look at this for a minute because we have endpoints. Let's look at the first one. I'm going to cover up the second one for now. So let's just look at that first one. And what I want you to do is work on that for a minute. Find your X and Y coordinates from the choices here, because this is how your test or your assignment, quizzes, practice will present the questions, and sometimes that's confusing. So what we're going to do is take 5 and -1. Well, let's try to get started on this. Thank you. That is 4. Thank you. And now divide by 2. What is 4 divided by 2? So it's not going to be this first one, the second one, the third one, the fourth one. It could be the fifth or sixth choice. So look here. Okay, now we've got radicals. Don't let that scare you. You know how to do this. Add this. We have 1 square root of 3 and 5 square roots of 3. What is 1 plus 5? 6. 6 square roots of 3. Very good. Now divide that by 2. And what is your final answer? Is it 3 square roots of 3 or 2 square roots of 3? Thank you. That's right. Azur, Bagarvi, Khadijah. So does somebody want to go to the board and drag that answer, or just draw a line from that answer up to this box? Or do y'all want me to do it? All right, it's your turn. You need to type the answer in. Okay, do it. Go ahead, Azur. I want y'all to do it. All right, you need tools. Does it work now? How about now? All right, I guess it's not working because I've got them turned on. I'm not sure what's happening with Neuro today. All right, type in the chat box what the answer is. 2 and 3 square roots of 3 or 2 and 2 square roots of 3. Put your answer in the chat box and I'll draw the line. Okay, thank you. Because we had 6 and we divided by 2. So it's 2 and 3 square roots of 3. Check. Make sure you're checking my work because I'm at the board and sometimes I forget. Is that right? All right, let's look at the next one. Let's do this one together. All right, now we have fractions. So let's practice with our fractions. We have -1/3 plus +1/3. Add those two together. We have a common denominator of thirds. So we add the numerators. -1 plus +4 is, all right, Khadijah, you may be ahead of me because that doesn't look right. 4 minus 1 is 3.
Yeah, sorry, I was kind of ahead.
Yeah, well, I'm slow, so you got to slow down for me. One thing at a time. All right, so now I see where you're coming from. 3 divided by 3 is 1. All right, so we're looking for that x coordinate of 1, so it's not going to be this one, this one, this one. Oh, I forgot to do something. What did I forget to do? I was so proud of myself. I found an answer, and that's a common mistake, that I just jumped out there and looked for that answer. I forgot to divide by 2. Is it going to be a positive 1/2 or negative 1/2? Okay, y'all are saying positive, so there's positive, negative, no. That's not 1/2. So there's only one answer choice, but let's check the y coordinate just to make sure, okay? So now for the y, we're going to add 7/5 and 5/2. So here's a challenge. 7/5 plus 5/2 is what? We need a common denominator, so you would multiply by 2 over 2 and 5 over 5 to get a common denominator of 10. Okay, and so this would be 14 plus 25 . I'm waiting for somebody to help me. What'd you get there? 14 plus 25 is 39 over 10. Or is it 39 over 20? Right here. Okay, but I agree with you. The only choice we have is 20, but I think our common denominator is 10. So I think that we don't even have an answer choice. So it's 39 over 10. We don't add the denominators. So gosh, y'all are just thinking, y'all are really picking out the mistakes that I make, which is great. We don't add the denominators. You're thinking very deep and you're getting the right answer. So it's 1/2. It's not even up there. 1/2 and then 39 over 10. I'm so sorry, Star. I'm going to record this and put it in the I can. Okay, we have one more, and then we're going to do the drawing. All right, for this question, it says, how are the coordinates of the other endpoint given expressed in terms of x and y? So we're extending or pushing you a little bit to work with numbers that are other than just simple whole numbers. We've already dealt with fractions, now we're dealing with expressions. So take your time and watch this example. All right, we have one endpoint of a line segment that has coordinates represented by x plus 6. So this is where it gets tricky. Here's our expression. You need to pull that apart and remind yourself that that's our x coordinate. Okay, even though the expression has x in it, that's where you might get confused. So this whole expression, x plus 6, is our x value. And our y value, it also has a y in it. This is going to be our number associated with our coordinate. It's our y value or our y coordinate. So we have an x and a y, but they're not, again, simple numbers. So we're going to use the same formula. Remember, we're adding the x's and we're adding the y's and we're dividing by 2. Now here's one endpoint. So this is going to be an x plus 6, and this is going to be a y value, 1/3 y. But we're not given the other endpoint, we're given the midpoint. So here's where I'm going to demonstrate. Let me change my pen color. Here's where I demonstrate how to write this. So we have an x and a y coordinate. So the midpoint is 2, -5. See where the big M is up here in our formula? All right, but I've got to pull this apart and just look at the x value. So let's take our x value, and we're going to write this equation as 2 is equal to, well, let's think about this. 2 is equal to our 2 x's added together and divided by 2. So I know I'm going to divide by 2. So what are we adding together? This is where it gets tricky. Remember, our x is an expression, x plus 6. Now we've got x's all over the place, and we're going to be adding another x coordinate that we don't have. So I'm going to say x plus 6 is my first x coordinate, x sub a or x sub 1, however you labeled it. And then that other x we don't have. So I'm going to call it any other variable besides x. So let me call it n for number. Okay? Now we're going to do the same thing with the y value. So I've got -5. That's our midpoint, our y value midpoint. So to get our y value for the midpoint, we take our 2 y values and we add them together and divide by 2. That dividing by 2 is not going to change. All right, so let's look at what our y values are. Our first one is the expression 1/3 y. but we don't have our other y value. So let me write this line out. So we're going to add our other y value, but we don't have it. So let me use a variable. So I've already used n, I've already used x and y. So let me say m. Normally don't use m when we're talking about midpoint, but I think that this is going to be okay here. Just as long as we have something different. So I've got two expressions I need to isolate. The first one for n and the second one for m. So I'm going to start off by multiplying both sides of the equation by 2. 2 times that fraction expression. And the 2 is going to cancel out. But over here we have 4. So 4 is equal to x plus 6 plus n. Now remember, we're trying to isolate n, not x. So we're going to subtract the x and the 6 from both sides. So we'll put that over here, minus x minus 6. And then we already have a positive 4 over here. All right, this is going to cancel out. We have 0, 0. And we have n is equal to whatever this expression is simplified. So let me go ahead and add my constants together. Negative 6 plus 4 is negative 2. And then we have that negative x. So n is equal to negative x minus 2. That is the other endpoint, the x-coordinate. So now let's find the y-coordinate. So this time we're going to isolate for m. So we'll do the same thing. We'll multiply both sides by 2. Now there's different ways to approach this, so if you're doing it a different way, as long as you're following the rules for algebra and reverse order of operations, being very careful with your positive and negative signs, you should get the same answer. My way is not the only way. So 2, and a lot of times my way doesn't give me the right answer, so you can challenge my answers. So 2 plus negative 5 is negative 3. So negative 3 is equal to, now that the 2 cancels, we're left with 1/3 y plus n. All right, so all we have left to do is subtract 1/3 y from both sides. And we have a variable here, negative 1/3 y, so we can't combine it with the negative 3. We just have to write it as that expression. But over here, these two things cancel out. That's 0. So we're left with negative 1/3 y minus 3 is equal to m. Okay, so we have our x, which we called n. That's negative x minus 2. And we have our y of the other endpoint, which we called m, to solve and get this answer, negative 1/3 y minus 3. All right, so we would write it like this, negative x minus 2, comma, negative 1/3 y minus 3. All right, now this it just takes a little more concentration, but we're basically doing the same thing that we've always done with midpoint. All right, I hope this helps. Okay, but let's do you have to be in class to win the $25 gift card. So there's a lot of ways for you to get your name. classroom positive behavior, positive communication, asking questions, supporting others, completing assignments. Go ahead.
The exit ticket's not loaded up.
Let me just send it out to all of y'all in an email. You can complete it later, okay? So because we've been stressing out because of what's happening here. So let's just go ahead and spin. How's that sound? All right, if you're here, you've got to type in the chat box that you're here because I'll give you 10 seconds and then we move on. You got to see your name first. Are you here? Type in the chat box if you're here. Here, everybody give her a round of applause. Congratulations. All right, send me an email and tell me what email you want me to send your reward to. All right, we've had some struggle here. So go ahead and keep working. You've got 2 assignments to do, right? The exit ticket, I'll send you a link that you can complete on your own. We've got 1 more minute, but I don't want you to struggle anymore because y'all have hung out and you get your name in the next unit, at the end of next unit, for being in class today, for participating and being positive. All right, we do have Help Lab today at 4:15 and tomorrow if y'all want to come in. I'm going to hang out another 5 minutes if you've got questions. All right, you're free to go. Thanks for coming.